This is Unit 7, Section 8, Base E and Natural Logs. Now yeah, the base E, that's not a typo, it's actually an E. E is an irrational number. You can see it all over the paper here. I have E, well not there, but there's E again. So E is a number. It's an irrational number, meaning it never ends. It's just like pi. If you want to know, it's like, what, 2.72 is like the rounded version. Like pi is 3.14, E is 2.72. So if you need to know that, you can. I'm never going to use it because I want to leave my answers in exact form. So anytime I write an E, I'm going to leave E alone. Okay, so write each equation in the inverse form. Well, this is just like we've been doing this whole chapter, where I have a base with an exponent equals a number, and I switch it and do log base of the number equals the exponent. Only this time it looks different because I have an E, and if you notice on 2 I have ln. That's called a natural log. That's why I don't know why it's ln, but you would think they would do it in L for natural log, but I think they do it like log natural, just so you know it's either log or ln. I'm not really sure why the order is, but here's how I do this. So if I have E to some exponent equals A, the way I would convert that is I would do natural log of A equals my exponent. So it's practically the same thing we've been doing with exponential functions, except now I replace a number with E, and instead of writing log, I write ln. That is the only difference. Okay, and I can go back and forth. I can convert either way with this. That's fine. So if I start at E, I can go to log or natural log. If I start at natural log, I can go to E. Either way. So this last section is all about how to do the same thing we've been doing, but instead of using numbers and log, I'm going to use E and natural log. So hopefully this will be kind of a review with just a minor change. It's not really that bad. Alright, so here, if you want to label these, we can label. We have E. I don't know why that's that color. So I have E, X, and A. And to convert this from E, I would do natural log of A equals X. And notice I don't write a base because these are very similar to the base 10, where we just have a log with no number. If my base is E, I write natural log, because you could, if you really wanted to, you could write log E of some number, but no one does that, right? No one writes log E. That's why they came up with a natural log. So all I do is just take this and I rewrite it. So I already have my answer. I do natural log, and then A is 15 equals 2x plus 1. That's all I'm doing here. Because all it tells me to do on the directions is write in inverse form. So you convert it, and then that's it. There's nothing to solve for. Not yet. Alright, number 2. Now I'm going to convert the other way. So here's where you have to remember, every time you see natural log, that means your base is E. So B is E. That might look confusing, but base is E, which means this is my A, this is my X, and so I would write E to the X equals A. So my answer, because it's natural log, I have E to the X equals 5. And that would be my answer. So that's converting. I did one of each. Now your homework has a few more. I would definitely practice these. Even though they're very similar to what we've been doing, again it just replaces and puts in an E in natural log instead. So it's just recognizing that change. Alright, next one, condensing and expanding. Okay, I'm going to do the exact same thing I've been doing. The same thing applies to logs as they do to natural logs. When I add, you multiply. If I have a number in front, it becomes the exponent, and if I subtract, I divide. Nothing has changed there. So first thing I would do is take the number in front and change it to my exponent for each one of these. So that would give me ln of 64 to the 1/3 plus ln of x squared. Okay, I'm going to go ahead and do this because this 1/3, remember, is the same thing as a cube root of 64, which is 4, right? So I'm going to rewrite this as ln of 4 plus ln of x squared. Now my final step, because I am adding, I'm going to multiply 4 and x squared. So I have ln of 4 times x squared. So my final answer is ln natural log 4x squared. And that's it. So again, very similar to what we've been doing, exact same steps, you're just writing natural log instead of log. That's all you got to do. Alright, and then expanding, again, same rules apply. I would always get rid of or distribute any exponents if you have them. So this would give me natural log of a to the 6th, because 3 times 2, and then b squared. And then because I am dividing, I'd be subtracting. So I have natural log a to the 6th minus natural log of b squared. And then, of course, my exponents go out front. So I have 6 times natural log of a minus 2 times natural log of b. That would be my final answer. Okay? And let's move on. I think we have just, yep, this is the last part. So I want to solve natural logarithms and base E equations. Alright, so let's start with base E. These are very similar to the exponential ones we had, where whatever your base is, in this case, E is my base, and then your exponent, you want to get those by themselves, which means I have to move everything around that, so I have to move the 2, and I have to move the plus 3. So first thing I would do, subtract 3. So if you were good with that section that we did, this will be super easy. So I'm left with 2e to the x minus 9 equals 87 minus 3 is 84. Alright. Now, I still want the e by itself, so I have to get rid of that 2. So I divide by 2 on both sides. That gives me e to the x minus 9 equals 84 divided by 2 is 42. Okay, once the e is alone, just like before, we convert. So I want to have natural log of a equals x. So here's my x, here's my a. So when I write this, I would have natural log of 42 equals my exponent, x minus 9. Now I just solve for x by adding 9 to both sides. And just like before, I cannot change the number in parentheses. Therefore, I would have natural log 42 plus 9 equals x. And that's it for that one. Alright, last question. Now I'm going to do a natural log equation. So remember on this one, I have natural logs on both sides, so I want to condense everything as far as I can, and then I can cross off the natural log. So this 2 becomes the exponent. That would give me natural log m plus 4 squared equals natural log of 4. Now with one natural log on each side, I can cross the logs off just like we did. And then I'm left with m plus 4 squared equals 4. Okay, remember, if I square something, it's the same thing as having 2 of those. So I can write that twice. And now I can multiply. And if you remember this is like FOIL, so or distribute. So I multiply m times both and 4 times both. okay? So m times m is m squared. M times 4 is 4m. 4 times m is 4m. 4 times 4 is 16. And then I can combine like terms right here. M squared plus 8m plus 16 equals 4. And because I have a square, I want everything on the same side so that I can factor. So minus 4, minus 4. Alright, we're getting there. M squared plus 8m. 16 minus 4 is 12. Now I can factor. Yes. So 12, first times last is 12, right? And then I know I'm going to have two parentheses. What multiplies the 12 and adds to 8? 6 plus 2. Now I can solve. Set both of these equal to 0, or if you know the shortcut, use that. Subtract 6, subtract 2. So I get m is negative 6, m is negative 2, but I have two numbers. So just like with regular logs, I still have to plug these in to make sure that I don't have anything negative. So luckily I only have one thing to plug this into. So 2 and then natural log m plus 4. So I have 2 times natural log m plus 4. Alright, I'm going to plug it into that. I have negative 6, negative 2. So if I do 2 times natural log of negative 6 plus 4, that gives me negative 6 plus 4 is negative 2. Uh-oh, can't have a negative. So that one's out. Now I try the next one. 2 times natural log m plus 4, 2 times natural log of negative 2 plus 4. That gives me 2. Positive 2, that's okay. So my answer is m equals negative 2. See, just because the answer becomes negative doesn't mean that it void or cancels out or makes it not valid, okay? So you still have to check it, plug it in, make sure. Because even though the 2 was negative, it still kept the log positive, which is totally okay. Okay, so don't just cancel out any negative answers. That is not always going to work. And that's it for this section. Yes, awesome. And that's it for the chapter.